In this video, we'll explore the fundamental concept of density, which is essential for your GCSE Physics revision. Understanding density allows you to identify materials, predict if an object will sink or float, and solve exam questions with confidence. This revision session covers 5 key areas: the density formula, the necessary units and measurements, practical techniques for measuring density, the physics behind sinking and floating, and some essential exam tips. So what is density? Simply put, it measures how much mass is packed into a given volume. You can think of it as how crowded the particles are within a material. Dense materials, like lead, are heavy for their size, while low-density materials like foam are much lighter. The core of your density work is this formula. Density equals mass divided by volume. We use the Greek letter rho, or yo, to represent density. You can rearrange this equation to calculate mass or volume, as long as you know the other two values. Commit this formula to memory. Rho equals m divided by v. It is the foundation for every density calculation you will encounter in your physics exam. Using the correct units is vital for achieving full marks. Density is a derived unit. We measure mass in kilograms, volume in cubic meters, and density in kilograms per cubic meter. Here is a quick reference for the quantities, their symbols, and their SI units. Be very careful with your units before substituting them into your formulas. Mixing kilograms with cubic centimeters is a very common mistake. To measure mass, use a digital balance. Remember to zero or tare the balance before starting. Check your units, grams or kilograms, and take repeat measurements to calculate a mean, which improves the reliability of your results. Measuring volume depends on the object's shape. For regular objects, measure their dimensions and apply the geometric formula. For irregular objects, use water displacement, where the object pushes water out of the way. The volume of the displaced water equals the object's volume. For regular objects like a cuboid, use a ruler to measure the length, width, and height. Then, multiply these 3 values together. Finally, ensure your answer is recorded in the correct units, such as cubic meters or cubic centimeters. Let's walk through a quick example. First, measure the dimensions to find the volume. Next, weigh the object to find its mass. Finally, divide the mass by the volume to find the density. In this case, 2,700 kilograms per cubic meter indicates the metal is aluminium. For irregular objects, we rely on Archimedes' principle. If an object is submerged in water, the volume of water displaced is exactly equal to the volume of that object. This is a reliable method regardless of the object's shape. To use a measuring cylinder for displacement, first fill it with a known volume of water and record it. Carefully lower the object into the water. The new water level minus the initial volume gives you the volume of the object. Alternatively, a Eureka can is designed to collect displaced water accurately. Fill the can to the spout, submerge your object, and collect the water that flows out. The volume of this collected water is the volume of your object. Choosing between methods depends on the object size. Use a measuring cylinder for small items, but choose a Eureka can for larger or oddly shaped ones. Remember to watch out for parallax errors when reading scales, and always ensure the can is filled to the spout. Your GCSE course includes a required practical on density. You could face exam questions on the method, measurements, and data analysis, so ensure you understand the full procedure. Measure the mass, find the volume, and then calculate the density. When recording your results, precision is vital for high marks. Always use a clear results table with column headings that include the correct units. Additionally, match your significant figures to the precision of your original measurements, typically 2 or 3. To improve reliability, perform repeat measurements and calculate a mean. This process helps to reduce the effect of random errors, like slight variations in how you read an instrument, and gives you greater confidence in your final density value. This slide displays a sample results table. Notice the clear headings and organized structure, which help when identifying materials. By comparing your calculated density to known values, you can determine if a sample is aluminium, granite, or another substance. Density determines whether an object will sink or float in a liquid. If an object is denser than the liquid, it sinks. If it is less dense, it floats. If the densities are equal, the object will suspend within the liquid. Water is unique because its solid form, ice, is actually less dense than its liquid form. This property allows ice to float on top of water, which is a crucial factor in the survival of aquatic life during winter months. Familiarizing yourself with the density of common materials can help you check your work. These reference values allow you to verify if your calculations are realistic and help identify materials when working through exam problems. Density is everywhere. Large steel ships float by displacing water with a hull filled with air, lowering their overall density. Similarly, hot air balloons rise because heated air is less dense than the surrounding atmosphere, and submarines dive by taking on water ballast. The particle model explains why density varies. Heavy atoms generally lead to higher density, while the physical spacing between particles is key. Solids have tightly packed particles, whereas gases have particles spread far apart, resulting in much lower density. As you can see, the density of a substance changes dramatically across states of matter due to how particles are arranged. With the notable exception of water, most materials become less dense as they transition from a solid to a liquid, and then to a gas. Density is a powerful tool for identification. Beyond geology, it is used in fraud detection to verify if gold or silver items are authentic, and in industrial quality control to ensure manufactured components meet specific standards. Let's practice some calculations. Always check if you are calculating density, mass, or volume. For instance, in question 1, dividing the mass of the brick by its volume gives us 2,500 kilograms per cubic meter. Avoid these common exam mistakes. Never mix different unit systems like kilograms and centimeters. Ensure you divide mass by volume, not the other way around. And always include units in your final answer to avoid losing easy marks. When reading a measuring cylinder, avoid parallax error by keeping your eyes level with the water. Always read from the bottom of the meniscus, which is the curve the liquid forms, to ensure your volume measurement is accurate. To wrap up, here is a summary of the key formulas. Keep these relationships for density, mass, volume, and geometric calculations handy for your exam. Mastering these will help you solve any density-related question you might encounter. This structured approach, focusing on mass, volume, density, and repeat measurements, is key to securing full marks on your required practical questions. Use this method to keep your answers clear, concise, and accurate in the exam. Understanding floating and sinking is straightforward if you know the reference point. Water has a density of 1,000 kilograms per cubic meter. Ice, at 917 kilograms per cubic meter, floats because it is less dense. Steel is denser than water, but ships still float because the object as a whole, including trapped air, is less dense. Density is a vital tool outside the classroom. Engineers use it to select lightweight materials for aircraft. Oceanographers study density layers to understand climate patterns, and archaeologists use density to authenticate valuable items without damaging them. Spotting errors in calculations is great exam practice. Watch out for missing units like in student A's work, mismatched unit systems seen in student B's attempt, or inverted formulas like student C's, where they divided volume by mass instead of mass by volume. For exam calculations, follow this sequence. Write the formula first to earn method marks. Then, substitute your values clearly before performing the arithmetic. Finally, write your answer on a new line, always including the correct unit. Follow these top tips. Memorize the density formula in all its forms. Check your units match before calculating. Know whether to use a ruler or water displacement for volume. And remember that denser objects sink while less dense ones float. Test yourself with these questions. What is the formula for density? What are the SI units? How do you measure volume for irregular objects? Will an object with a density of 1,200 kilograms per cubic meter float? And why do we repeat measurements? Master this vocabulary. Remember that density is mass per unit volume. Displacement refers to fluid moved aside. A eureka measures the volume of irregular objects, and the meniscus is the curve of a liquid you must read from the bottom. To recap, density is mass divided by volume. Always ensure units are compatible. Choose the right volume method for your object, and use the sink or float rule to verify your logic. Once you grasp these basics, you'll be well prepared for any density exam question. To consolidate your learning, practice at least 10 exam-style calculations. Revisit your notes on the required practical to understand sources of error, connect density to the particle model, and keep a formula card ready for your final revision.